The time stack. Time is a stack, not a number. 8 layers. For this episode only, the whole stack lights at once, because today the stack itself is the map. You think a timestamp is one fact handed to you. It's actually the top of an 8-layer climb, and every layer below adds both precision and a small lie. At the very bottom, a quartz crystal vibrating tens of thousands of times a second. In a watch, exactly 32,768, 2 to the 15th. That is the raw tick. Everything above will count. A hardware counter turns those ticks into a running count. A tiny battery keeps it ticking even when the machine is off, so it still knows the time when it wakes up. The operating system reads that counter and hands your program now, but two kinds: wall clock time, which can jump when corrected, and monotonic time, which only ever moves forward, the one you must use to measure how long something took. To store it and send it around, we agree to represent time as one number, the count of seconds since one exact instant, midnight, the 1st of January 1970, UTC. That shared zero is the Unix epoch. Your number drifts because your crystal isn't perfect. NTP, the Network Time Protocol, asks a better clock for the time, measures the network delay, computes how far off you are, and slowly nudges you back. It slews. It doesn't usually jump. But whose clock did NTP ask? A chain of trust. Stratum 0 is the real reference, an atomic clock or a GPS receiver. Stratum 1 sits right next to it. Stratum 2 syncs to 1, and so on. The lower the stratum, the closer to truth. Now we make it human. Apply a time zone, maybe daylight saving, and the occasional leap second, and the tidy number becomes the messy wall clock time people actually read. This layer is where most time bugs are born. And at the top, the hardest layer, agreeing across machines. No two clocks share an exact now, so distributed systems don't ask what time is it. They ask, did A happen before B, using logical clocks and uncertainty intervals to order events safely. So this is the climb. One tick at the bottom. 8 layers later, a timestamp the whole internet will trust. Every later episode zooms into exactly one of these boxes. 3 truths cut across every layer, the way noise runs through a whole signal chain. Clocks drift and skew. Precision is not accuracy. A timestamp with 9 decimal places can still be flat wrong. And every clock, at every layer, carries uncertainty. A timestamp is an agreement, not a fact. Next, why the crystal at the bottom is already wrong.